All right, let's look at homework 16.7, problem number 9. All right, so a fluid has density 840 kilograms per cubic meters. So this is our rho, right? So we have, this is our rho, so then density, and we have velocity given, right? So we can let F to be simply rho times vector field V. So in this case, rho is 840, and then vector V is Z, comma, y squared, comma, x squared. All right. Then let's see, we're talking about the cylinder here, so we have to come up with the parameterization of the cylinder. So we can probably just use the cylindrical coordinates, and in this case radius is 4, because 4 squared is 16. So we can use 4 cosine of theta for x, and 4 sine of theta for y, and we can use z as z, right? All right, then we can find the cross product of partial of r with respect to theta, cross product with partial of r with respect to z, right? So this is going to be, right, vector I is a vector j and vector k. All right, so partial with respect to theta is going to be negative 4 sine of theta, and here is a 4 cosine of theta. All right, partial z with respect to theta is 0. Right, and partial with respect to z would be, that would be 0 here, partial that is 0, and partial z with respect to z is 1, right? So this is going to be, right, first component is 4 cosine of theta. Right, second component is 4 sine of theta. And the last component is actually 0. Right? So what we're looking for is we're doing, so we want to find the, let's see, the surface integral over the surface S, which is this cylinder. And then we're going to have F dot d vector surface S. All right, so this can be set up as, so let's just set this up. All right, so F is this guy, but in this parameterization, all right, Z is Z. All right, y squared would be 4 sine theta squared, so it's going to be 16 sine squared of theta. All right, and x squared, so that's going to be 16 cosine squared of theta. And then we have this rho, which is 840. So I actually need a little bit of more room here. So I'm going to put 840 here. All right, and the dot product with this cross product here, so 4 cosine of theta, comma 4 sine of theta, comma 0. Then we have a d theta, dz. All right, so in this case, theta, we can do either 0 to 2 pi or negative pi to positive pi. We just have to go around once. So I'm going to actually use negative pi to positive pi so that we can simplify things a little bit more easily. And then z is going from 0 to 4. So 0 to 4. Alright, so let's multiply it out. So you have, so 840 is still out here. Right, I'm going to have an integral from 0 to 4 and an integral from negative pi to positive pi. Right, multiply out. So you're going to have, let's see, 4 cosine of theta times z plus, right, 4 times 16 would be 64. Right, then you have a sine cube of theta. Alright, then 0 times anything is 0, so you just get that. Alright, so we have that with respect to theta, with respect to z. Alright, so since theta is going from negative pi to positive pi, if you have an odd function, it's going to be 0. So you can see that here, sine cubed of theta, so this guy is an odd function. Right, so which means that the integral from negative pi to pi is going to end up being 0. So I'm going to scratch that out. Right, then here we can separate into, so this is going to be 840. Alright, so I'm going to do z first. So I'm going to have integral from 0 to 4 z with respect to z. So these are separable. Then you have an integral from negative pi to positive pi. Then you have a 4 cosine of theta d theta. Right? And then this is equal to, so you have 840. Antiderivative of z is z squared over 2. Then we're going from 0 to 4. Right, we can actually cancel 2 on the bottom, and this is going to be 420. Right? Then multiply by antiderivative of 4 cosine of theta is 4 sine of theta. Then you're going from negative pi to positive pi. Alright, but as you can see that here, if you plug in pi, sine of pi is 0, and sine of negative pi is actually 0 as well. So we see that this is actually 0. So it really didn't matter what you have in front, it's still going to be 0. So this is going to be equal to 0. Alright, let's type it in. Alright, so we got 0 there. Alright, let's check the answer. Alright, actually came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.